Thus far, we have converted both SUSE and Red Hat boxes to LDAP, which means via the NSS or name service switch configuration interface, both systems can now authenticate against both local etc password, etc shadow, as well as LDAP. But we've yet to convert Solaris10, so let's spend this section showing you how to set up LDAP as a client on Solaris10 so that the Solaris10 server also performs like the Red Hat and SUSE boxes. So Solaris10 migration. Now we're running Solaris10 10.08. However, the migration has been the same throughout Solaris10 with minor changes with respect to PAM in terms of supported options within the PAM configuration file. But by and large, the steps are the same. So if you're running an older or newer version of Solaris10, just look for differential here, as we do with all distributions. You should be okay, plus or minus any small nuances. So what's involved with setting up Solaris10? Well, a number of things. First and foremost, all along we've been running with a limited schema set on the Solaris10 box because the default OpenLDAP implementation does not load the additional schemas such as cosign and inet.org person, which are required in order to replicate the directory. So all along, if we execute LDAP search from the Solaris perspective, we will not or would not have seen the user accounts databases. So that said, our first task is going to be to update the schema set to ensure that the OpenLDAP loads the additional schemas. So let's just list some basic information such as the features, and it permits Solaris10 box to authenticate users against local and LDAP, and by local obviously we mean etc password, etc., etc shadow, and LDAP, just like with the SUSE and Red Hat implementations thus far, which means we can take part in this distributed user accounts database. Solaris10 running OpenLDAP, and for consistency we suggest that you use OpenLDAP as opposed to Sun's directory server or some other LDAP. So Solaris10 OpenLDAP can participate in directory base user authentication, which reiterates the first feature. And there are a number of steps. So the steps or tasks include: ensure that Solaris10 OpenLDAP loads similar schemas in slapd.conf. To determine what those schemas are, we'll navigate to either the Red Hat or SUSE Enterprise 10 box. Now, since the SUSE box is our primary, we'll navigate there and confirm. So we have a window here open. Let's navigate into etc OpenLDAP, and we will take a look at the first section or the first block of configuration directives in slapd.conf, where the individual items are included, the individual schema files are included. Here's the schema block. These are the items that are included. Now we can ignore yas.schema, and if there is no RFC 2307 BIS schema on the Solaris side. However, we do need inet.org person, which requires cosign schema, which requires core schema. So these are the three that we want to load all together: core, cosign, and inet.org person, as they provide the requisite object classes. So let's just list, but the directory paths need to be updated to reflect the location on the Solaris side. Now, if you recall, when we installed OpenLDAP, it was deposited beneath the directory structure user, local, etc, etc, and we can confirm as such from our bash shell on the remote system. We'll navigate to user, local, etc OpenLDAP. This is the directory structure So we need to update our configuration to point to this structure followed by the schema subdirectory, and LSL will reveal those items. So here lies the schema files that come with OpenLDAP regardless of distribution, and we want to provide support for cosine as well as inet.org person. And if you do any work with NIS, consider using or including the NIS schema as well. So the path will be user local etc OpenLDAP schema. Let's just prefix this with user local. And now we'll be able to include these two schemas again. They're both important to provide the object classes necessary to support the attributes we found by executing LDAP search on both Red Hat and SUSE boxes. So let's copy these two include statements and update our file. One level up, we'll modify slapd.conf. And below the initial include for the core schema, which is required, we'll include the two new schemas, cosine and inet.org person. That'll provide support for the attributes necessary. Now, if you recall, when we migrated the users, we did not, both from the SUSE and Red Hat boxes, we did not include support using the migrate scripts for extended schema. We can at this point, since inet.org person is loaded, turn on extended schema, but that's only if you make use of those attributes that are included with the extended schema, which are most of the attributes found in inet.org person associated with a user. So with that said, we have support loaded, but of course we need to restart the slapd instance for it to take place. So if we kill the current instance of slapd, now the proper way to kill it is to use the kill command plus the PID. If we psef grep slap, we see that it's running with a PID of 10,654. Additionally, the slap instance deposits its item beneath user local var, and in the run directory the PID file exists. So if we cat the contents of slapd.pid, we'll see the process ID. In this case, it's in the process ID of 7829. Let's psef grep 7829 to see what it's tied to, and we see indeed. So we pulled the process ID for something else. So 7829 is indeed slapd. Let's psef grep again slapd to be sure, and indeed it's slapd. The process ID that we pulled reflected the grep process that we executed in search of slapd. So the proper PID, lucky thing we checked the file, is 7829. Otherwise we would have killed a non-existing process. So the standard Unix way, which transfers over to Linux as well, for killing this PID is to use the kill command in conjunction with the cat process, which will, with the help of backticks, take as an argument the PID to be killed and pass it in as the first argument to the kill process. Sounds a bit confusing, but we'll show you how that works if you don't have that experience. So the next task is to restart slapd. Now we can kill using a hang-up signal, or we can kill it and manually restart it. So kill, and the PID will be exposed if we execute cat user local, and the full path to the PID, which is user local var run slapd.pid. Slapd.pid. Notice we've used backticks as opposed to single quotes. This takes advantage of a built-in shell feature called command substitution, which sends the output of cat and the slapd.pid file into the input of kill as its first argument. So this will kill the process, and then a restart will be just to simply execute slapd. Let's echo the exit status, and that's psef grep slap, and it's not running. This is again the grep process, which is no longer resident. So now to restart slapd, just execute the full path to it, and that'll start it. Let's go ahead and restart it, and echo the exit status again to be sure that it executed properly, followed by a psef grep, and now slapd is up as PID 10668, and the slapd.pid file should confirm as such. Perfect. So now we're up and running with the appropriate schemas to take advantage of the additional attributes that are already supported on both SUSE and Red Hat Enterprise boxes. So we've got a lot more to do to get this box on board with LDAP configuration. So now that it's up, it's able to participate fully with the additional attributes. We should confirm that we can enumerate those other users by using LDAP search. So LDAP search to reveal users in DIT that we could not see prior to, although we didn't execute an LDAP search during our studies to prove it thus far. But if you don't have the appropriate schema support, then you'll be unable to list objects that participate or derive their attributes from that particular or those particular schemas. So let's find a recent example of LDAP search, and now we see many records. That's an LDAP search from the base DN of all objects. So now we see the users that were imported, and if we want to get a count of items returned or matched, turn on verbose, it returns 34, and as we scroll through the list, we'll see entries for the different daemon accounts that were imported as a result of the migrate process, the migrate script. So now we know our cosine and inet.org person schemas are at play, although there are no inet.org person schemas in use at this particular point, but there are definitely cosine schema attributes in use. So how do we get our box to participate? Well, we've updated slapd.conf to load the schemas. We need to run a utility provided by Sun Microsystem named LDAP client. It's included with your distribution. So use LDAP client to configure the Solaris10 box as an LDAP client. This client performs a number of steps for us, including updating or copying over NSS switch or nsswitch.conf.ldap or nsswitch.ldap to nsswitch.conf. So it prepares the system as an LDAP client, and it also copies over the nsswitch.ldap file to nsswitch.conf. So we should just note LDAP client prepares Solaris10 box to be an LDAP client, and it copies etc nsswitch.ldap to etc nsswitch.conf. The nsswitch.ldap comes with Solaris10, and it includes the appropriate values for the appropriate tables when consulting both local files and LDAP. Now, there will be some modifications that we'll need to make, some tweaks to improve performance with respect to name resolution of hosts, etc. But for the most part, as far as authentication is concerned, nsswitch.ldap has all of the values that we need. Now, LDAP client supports numerous options, many options, which allow you to configure your server, your Solaris10 box, as an LDAP client. It facilitates, for example, automatic configuration, where after having placed an LDAP client on an LDAP server in the directory information tree, you can configure subsequent hosts automatically based on that configuration. It also allows you to configure the client manually, which is what we prefer, because you're able to specify on the command line exactly what you want the LDAP client to do, so which is what we're going to do. So we're going to write a long command which includes the options that are important to us. They begin with LDAP client. We'll turn on V. We want to manually configure the client. And if you execute LDAP client with help, you'll see many of these options. And if you furthermore execute man space LDAP client, you'll see all of the options that are supported. And there are numerous options, including we want to specify the default server list. Now, there are 2 other LDAP servers. We want to take advantage of that. We are configuring the Solaris 10 box, but both Red Hat and SUSE 10 are LDAP servers, so we can instruct the Solaris 10 box to consult both by using the default server list. And in between quotes, we can indicate a number of servers specified by spaces. So we can either specify the host name or the IP address. If your host name configuration is solid, then indicate the host name. But if you want it to work all the time and you're sure that the IP address or addresses of the LDAP servers will not change, then indicate the IP address. So in this case, the IP address of the first server is 192.168.75.19. Space, not comma or semicolon or quote, or colon, that is, the secondary server's IP address, which is 192.168.75.21. So we've got 2 IP addresses specified as LDAP lookups. In the event that one's down the primary, then the LDAP client on the Solaris 10 box will search for authentication on the secondary. Now we continue options by indicating subsequent -a's, lowercase a's. And the order is unimportant. You can indicate your options in any order you see fit. We want to specify the default search base. This tells the LDAP client, the Solaris 10 box, meaning the client resolver, the LDAP client that NS Switch will take advantage of, to search a specific area of the LDAP tree. Now, we can send the Solaris 10 box to a given branch, such as OU equals people, engineering, group, which we don't show here because we haven't updated the graphics, sales, and others, or we can simply send it to the root and tell it to search the subtrees. Now obviously this will not perform as quickly in larger DITs as will a specific search, but nonetheless it does the job, and if you have a small DIT, it's not a big deal. And again, keep in mind, as we've mentioned earlier, that LDAP is optimized for reads. As a consequence, even deep searches should be returned relatively quickly, because LDAP is, after all, a read-intensive or a read-focused protocol. So we want to indicate the default search base. And to keep things simple, we will indicate that the default search base is simply DC equals Linux CBT, DC equals internal. Well, we can always drop this a level to a specific OU, or we can go as far as indicating which services are tied to or mapped to certain OUs. So we can map services such as password, group, etc. to specific OUs. So now we've got a search base, let's indicate an authentication method. And since we're currently not using encryption, we'll indicate simple. Another important feature, and that is the search scope. The default search scope is the level at which you place the LDAP client, meaning if you place it at the root, it searches the root. It will not search sub-objects. So we want to change that behavior by indicating default search scope equals sub. Again, no need to memorize these directives and values or name value pairs. A man space LDAP client will give you everything you need to know. Let's just place that right above here. Note, use man LDAP client to learn about various options, configuration options. Let's continue. This command's getting longer, but it's not the longest by any means. Now, we should specify 2 additional directives, proxy DN and proxy password. These directives will allow the LDAP client to connect to the LDAP server as the root DN in order to read passwords. So we'll indicate a proxy DN and set it equal to CN equals manager, DC equals Linux CBT, just as it's specified in slapd.conf, DC equals internal, and a password to go along with that. Now this information won't be visible after we execute it. It's simply just to configure the client. So we've got proxy password, proxy DN, default search scope, authentication method, default search base, default server list, we've indicated that this is to be executed manually. Now we'd like to tack on one additional option, and this is to ensure that the PAM_LDAP module authenticates using simple authentication as opposed to TLS. So let's just indicate as such, although the default is usually fine, but we just want to be sure that we've indicated, because the slightest misconfiguration of LDAP client will cause your client to be unable to authenticate against a directory. So it's better we spell everything out that matters to us. So PAM_LDAP, the module that's used to tie the services on the Solaris box, such as SSH, login, PPP, etc., to the authentication source, will use the simple mechanism. So here's our long command. Now let's go ahead and copy this and paste it into our terminal window on the Solaris box. We are logged in as root. You need to be root. Whoami is currently not in the path, so we can't find it. So let's go ahead and paste. And this should run through rather quickly, providing no errors, of course. And it's gone through. It's already configured it that quickly. Now if we scroll to the end of the output, we will see what LDAP client has derived from what we've indicated on the command line. Here are the arguments. Authentication method simple, service authentication method simple, default search base, the proxy DN, search scope, proxy password, and the list of servers to be used. So the client's been configured, and we can confirm as such, which is our next step, using the LDAP client itself. So the next task is to use LDAP client space list to confirm LDAP client configuration. This will tell us whether or not the Solaris10 box is able to access the LDAP server. If this client is able to access the server, then we can move on with further configuration of LDAP. Also notice that the original etcnsswitch.conf was backed up to var LDAP restore nsswitch.conf. And the LDAP client, the native Solaris LDAP client, not the open LDAP client, was started. It is a separate service which runs, and it is running. If there was an error starting that particular network service, we would have seen as such. So let's execute LDAP client list and evaluate the results. So according to LDAP client list, this is the bind DN, this is the bind password encrypted, of course, the servers to be used, base DN, auth method, sub, etc. So LDAP client is happy, and as mentioned, the files are backed up. The nsswitch.conf file is backed up beneath var LDAP. Now, beneath var LDAP lies the information, the cached information related to the state of affairs with respect to LDAP client connectivity from the Solaris10 box to the LDAP server, one or more. There's a cache manager, credentials file, and a client file, and there is a restore subdirectory in the event you need to back out. Here's the original nsswitch.conf as well as default domain file. The domain of your host gets updated to match that of the connectivity to LDAP, which is why this file is backed up in the event that there was a difference and it throws off some other program that relies upon it. It's a good idea when configuring Solaris 10 that you use the same domain name as that tied to LDAP. So with that said, let's move on. Let's take a look at etc. We'll modify nsswitch.conf. That's going to be our next step. Let's list this as step C. We'll list it as tweak nsswitch.conf for performance. And we'll see that momentarily. Now, we will of course focus on the lines that aren't commented. For password resolution, the name service switch interface will use files, then LDAP, which means If you try to log in as root or a user that exists in etc password, it'll first consult etc password, and if it doesn't find the user, then consult LDAP. Same thing for group. If a group is referenced, such as when using chown or change mod, or user add or user mod, then the name service switch will consult first the files, which is etc group in the case of groups, and then LDAP in search of the group name that you're referencing from the tool that you've used, such as chown, change mod, user add, etc. Now this is where we begin to make changes. We'll comment what's there, Control K to cut it, Control U twice to paste it, and then modify hosts so that it uses files for resolution. We want files to be consulted because we have not migrated our hosts file into LDAP. And we'll use DNS as a backup if a host is unresolvable via the etc hosts file. So that's one modification. Another one is IP nodes. This will also be updated to be files. So let's Control K, paste it twice, comment the first one, and change this to files. And then DNS. We prefer files and DNS because those components are in place. We have not migrated IP nodes, hosts, etc. into LDAP. Ditto for networks, protocols, etc. Let's cut this block. In fact, we can cut the whole thing. Paste it once, paste it twice, comment the entire first block. None of these items are defined elsewhere, so with that said, let's change it. Files, protocols, RPC, ethers, services, etc. all should come from files. These are files that are defined in etc. We have not migrated these tables to LDAP once again, which is why we're not referencing LDAP. And even if we did, it usually makes more sense to reference these items from the local file system, unless of course you don't use a distributed database like DNS and want to take advantage of LDAP, but faster resolution comes from the local file system as opposed to across the wire. Now the other items are pretty straightforward. We'll include files for netgroup just to make it consistent, and we want to be sure that services consults files and then optionally LDAP. So this is one efficiency that was built into the NSSwitch.LDAP that was included with this release of Solaris, but the rest were not converted, because the assumption is you'd use the migrate tools perhaps to move all of your information into LDAP and just query LDAP altogether. So we've tweaked the key entries for the different databases that are of interest that we want to be local as opposed to remote. So with that said, we need to update the PAM environment. Now, a quick test to determine whether or not this Solaris system can access the LDAP database is to use getEnt. So step D, use getEnt password to enumerate local and LDAP users. Let's copy this into memory. And we're missing the T here from getEnt. Let's try that again. And we'll paste that in. And there we see the various users. And again, there are some redundancies because we imported users from the SUSE box, which duplicate or coincide with users on both Solaris and Red Hat, such as @, etc., www-run. However, of importance are the users we've been testing: Linux CBT SUSE 2, Linux CBT or LCBT RH Local 1, and Linux CBT LDAP test. These are all LDAP users. So this is important. These are the users we're interested in because they come from the LDAP database. We haven't migrated any groups, so if we execute getEnt group, for example, it returns a list of local groups. But if we use the migrate scripts to migrate groups, that we create on any of the boxes into the LDAP DIT, then getEnt group will show those objects. Now, the next area of concern is to update the pluggable authentication modules interface. So step 4, update PAM configuration. Now, in the interest of saving time and avoiding confusion, we have concluded that the best way to move forward is to have created up front a pam.conf and then just show you the changes and include it in the docs subdirectory so you can compare and contrast to yours. This is one area of confusion on the internet in terms of what exactly is the right pam.configuration file to enable Solaris10 to authenticate services against LDAP. Services such as SSH, login from the shell itself, PPP, FTP, Apache, anything that could possibly use PAM. So we're going to back up existing etcpam.conf file and copy predefined etcpam.conf.ldap file to etcpam.conf. Now, before moving forward, what we should try to do is log in locally as an LDAP user. Let's try to log in as lcbtrhlocal1 at localhost. It prompts us for password, and it doesn't work. We can try any of the LDAP users, it will not work. And that is because PAM is not properly configured. It's still configured to authenticate only against etc password using the traditional PAM_Unix module, which consults etc password shadow to determine whether or not a user is authorized or has authenticated successfully and authorized to use the system. So PAM must be configured. Now, as mentioned, we have our own PAM file here. This is pam.conf.ldap. First, we'll back up pam.conf to pam.conf.back. We have a previous version there. Then we'll back or copy pam.conf.ldap to pam.conf. And then we can explore both. Let's less pam.conf.back. This is the original file. This file contains no references to LDAP. For example, if you are at the console and you're using the login process, the traditional PAM_Unix auth module is consulted to authenticate you to the server. If you're using rlogin, PAM_Unix auth as well as other modules are consulted. RSH, so on and so forth. PAM allows the administrator to specify or map services to modules, which is why we see various services ranging from login to PPP to other. So these services reference modules that take care of authentication, authorization, and so on. So nowhere in this document do we see references to LDAP. However, when we take a look at our new pam.conf, the one we've modified, we've created sections, and again, this file is in your docs subdirectory of this release of Linux CVT. We've created LDAP sections, for example, for the login process, which handles logins from the console. We've created or updated the auth section such that PAM_Unix auth is required or PAM_LDAP is required, and we actually have debug turned on. This can be turned off. This creates entries. This setting creates entries in the log file to help you debug authentication issues, if there are any. Now, we're not concerned with rlogin, so let's keep going further, but for any service that you want LDAP authentication to work with, such as rlogin, mimic what we've done, which is after the Unix auth line, include a line for LDAP. So we'll move on, and we'll see a new LDAP block momentarily in the other section. Other means for other services outside of the ones that have been listed thus far. So here we have two entries. If the user uses PAM_UnixAuth, then authentication is considered to be sufficient. PAM_UnixAuth would be used if a user is authenticated against the local etc password file. However, if the user uses PAM_LDAP, then authentication will be required or will be good as well. So in this case, either or will suffice. Down in the password section, we've included beneath PAM_password_auth a PAM_LDAP reference. This is all for authentication. And that's it. Those are all the references in pam.conf to make LDAP work. Now, PAM works in hot mode, if you will. It doesn't require that you restart it because there's nothing to restart. It's a module, or a series of modules that is, that are consulted at runtime. So let's just note, changes to PAM take effect immediately. As PAM represents a collection of modules that are referenced at runtime by the calling application, i.e. SSH, login, Apache, and so on. Now with that said, our fifth task is to simply try to log in using SSH. Attempt SSH-based login, which will authenticate using LDAP. And we know this because the user that will try belongs to the LDAP database, or directory information tree. So we will SSH as lcbt rh local1 at localhost on the Sunbox. And let's just get int once more to be sure we have the right username, and that's get int group. Let's try password. There's a user. Let's try it. lcbt rh local1. It prompts us, we'll authenticate, and it lets us in. Now there is an error. There is no home lcbt rh local1 on the Solaris box, and that's because Solaris defaults users to /export/home. So what this means is either we'll have to create symlinks or create an equivalent directory structure, but this is a small price to pay for now being able to take advantage of distributed users. So we're logged in as the user, but we just don't have a home directory. We can rectify this, of course. Let's navigate to the root of the file system, into home, and we'll make a directory named lcbt rh local1, and we'll make it owned by the same user using chown. And now when we LSL, we see that it's owned by lcbt rh local1. We could also make it owned by a generic group such as other. And let's try to log in again. And now it parks us in our home directory. Let's just note, set up environment for LDAP user. Chown, or make directory first, home lcbt rh1 or rh local1, followed by chown lcbt rh local1, and of course the directory name. and ditto for other users. Let's try to SSH from a different system, perhaps from the master server itself, the master LDAP server that is, as lcbt rh local 1 at linux cbt sun 1, and it lets us in. We're in our home directory. How about as the user linux lcbt susa2? Let's confirm that user. We'll get int, and let's try as this user lcbt susa2 at linux cbt sun 1, and it lets us in, but the directory doesn't exist, so of course that means we have to create the directory for the user. So let's go ahead and do so. We'll make directory followed by, if it's successful, chown of the directory. And it included a colon, which is why it didn't work. So we will chown the directory, and then now that it's chowned, well, we've dropped the connection that we didn't want to do. Let's try from the local system once more to log in and be parked into our home directory. And there it is, we're parked into our home directory. So again, if we grep lcbt susa2 local 1 from etc password, you'll see the user doesn't exist, which means the user is definitely coming from LDAP. So with that said, we've covered the steps to set up Solaris10 to authenticate against LDAP. The Solaris10 LDAP package is installed. It is a service. We mentioned we would show you that service. Services dumps a list of services, and if you grep LDAP, this is the service. This is the client service. So this service, or the package correlating to this service, should be installed. And in addition, your OpenLDAP open source version should be installed. This service is configured, as we've mentioned, using LDAP client. But before we got to LDAP client, we ensured that the slapd.conf loaded the additional schema files so that all of the servers are on the same page. All of the servers sharing a DIT are on the same page. We restarted slapd, causing it to load the new schemas. We searched to reveal users in the DIT that we were unable to see before on the Solaris side. We used LDAP client with a bunch of options. These options set up the Solaris10 box as an LDAP client of the OpenLDAP server framework, and we pointed it to two of the servers. One is a SUSE master, the other is a Red Hat secondary or slave server. We used LDAP client list to confirm connectivity. We tweaked nsswitch.conf, although the default works, but just to be sure that we don't run into problems later on, performance issues looking up items, we tweaked it. We used getEntPassword to be sure that the LDAP client could enumerate objects in the DIT as well as in the local etc password database. We updated the PAM configuration for the key areas, login, other, as well as for any other service that might matter. And we attempted to log in using DIT users, LDAP users. The environment wasn't auto set up as it is on the Red Hat side, and as it could be on any of the systems if we put the right PAM options in. But nonetheless, we created the environment. That's a small price to pay. And we're able to log in on any system based on the information from the DIT. So there it is, it's set up, and we'll move on to looking at other things we can do with LDAP.